One of the most important tools we have in chemistry is dimensional analysis as a means to convert from one type of unit to another. And an application of dimensional analysis is in something called stoichiometry, which is just a great word. It's a great vocabulary word. So I want to introduce you to the concept of stoichiometry today, and we'll work a problem together. The term stoichiometry, which again is kind of a funny word, comes from the Greek, which means measuring the elements. And what it does is to give us a way to convert from one element in a chemical reaction, one reactant or one product, to another. It's an incredibly practical means to get kind of from one piece of information about one particular element or compound or molecule to another. So the first thing you need to do in any chemical equation is to balance it out. So we need to make sure we have the same number and type of thing on both sides. That's that law of conservation of mass. So if we do a quick little accounting here of my sodium chloride, it looks like I have one sodium on this side, one on this side, so that's good. And then my chlorines, I have two on this side. Chlorine's one of our diatomic elements, so it has, paired with itself because it likes to share that those valence electrons. All right, so we have two chlorines on this side, but only one on this side. So we need to balance out the chemical equation by adding a 2 as a coefficient. That adds X as a multiplier. So we now have two sodiums and two chlorines. So my chlorines are happy, but I've messed up my sodiums. So I need to balance that out in that way. Okay, now that I have a balanced chemical equation, these coefficients tell us, if we're thinking on an individual atom and molecule level, how many of each of these species or how many of each of these things in this chemical reaction are reacting. So we could say I have two sodiums that react with one chlorine to give me two sodium chlorides. But we can also, because we've been talking a little bit about moles, we know that moles are a concept that we use to combine together large quantities of small, teeny tiny things. Then I actually have 2 moles of sodium that are reacting with 1 mole of chlorine to give me 2 moles of sodium chloride. So when we're thinking about our coefficients, the coefficients are tell us how many moles in this particular reaction are reacting. So that'd be 2 times my 6.02 times 10 to the 23rd, 1 times my 6.02 times 10 to the 23rd, and 2. Now this always feels a little bit weird. Oops, that's sodium, not nitrogen. This always feels a little bit weird to students because it looks like I'm saying 2 plus 1 is equal to 2, right? It looks like, if I was thinking in mathematical terms, like the math shouldn't line up. But it's really about the number of moles and the number of atoms that are in each of these particular chemical compounds. So it's 2 moles of sodium total, but I have 2 moles of sodium here because there's 2 moles of sodium in 2 moles of sodium chloride. And then we have 1 mole of chlorine that's diatomic. So I really have 2 moles of chlorine, and I have 2 moles of chlorine on this side as well. So again, that's a little tricky thing to get your head around, which is why when we're talking about molar quantities or molar ratios, which we'll get into in just a second, then it's really important to think about this in terms of the individual component pieces, because otherwise you can lose track. You can lose the forest through the trees there because it looks like 2 plus 1 is 2, but we need to be really specific with our units here. This is moles of sodium. This is moles of chlorine, moles of sodium chloride. Now the molar ratios we can get from this is, for every 2 moles of sodium, I get 2 moles of sodium chloride. Or for every 2 moles of sodium that I react, I have 1 mole of chlorine gas that I need, right? And we can think about them then as equalities, because if we think about them as equalities, then we can use them as unit converters. How exciting for us. Okay, so if we think about these equalities, then this gives me a way to convert from moles of sodium to moles of sodium chloride, right? It's a 1-to-1 ratio or 2-to-2 ratio. Or I can go from the number of moles of sodium that would be required to the number of moles of chlorine. So if I have a certain amount of sodium and I want to figure out how much chlorine I need, then this is the ratio I can use. But using these equalities give me a way to convert units. And so we can solve problems then that are incredibly practical and look something like this guy. All right. I'll do that. How about here? All right, if I have 5 grams of sodium in that reaction above, then how many grams of sodium chloride can I make? Now, this is incredibly practicable in an experimental sense. So if I'm going into the lab, this is a very practical way of thinking about things, because if I have a specific amount of starting material and I want to get to a specific product, then I have to figure out how much product I can make maximum from this amount of material, right? So if I have 5 grams of sodium laying around my lab, how many grams of sodium chloride am I going to be able to produce? Well, I can do the calculation first. I can calculate it out using stoichiometry, and then I can actually figure out and then I can actually go do it. And I have an expectation of what that final mass in this case is going to be. So incredibly practical stoichiometry. And here's how we do it. Here's the steps. Okay, so for our steps of stoichiometry in a given problem, you need to identify thing 1 and thing 2. Do you guys remember Dr. Seuss's Cat in the Hat? I like thinking about it in thing 1 and thing 2. It's a little bit Dr. Seussy in my head all of the time, but you could think about it as A and B if you prefer, or just 1 and 2. But I like thing 1 and thing 2 because I like the visual. So thing 1 is the thing that you are given information about. So in the problem, you have some information about how much of thing 1 you have. So you need to figure out which species, which thing in your chemical reaction is thing 1. And then thing 2 is going to be the thing that it's asking the question about. So when it says, how many grams of blank of what can you make, then that's going to be your thing 2. So we need to first figure out what is my thing 1 and what is my thing 2. And the fun thing about this step is once you've identified those 2 things, or A and B, or whatever you prefer, then you can completely ignore everything else. And that's kind of a nice feature because we just want to focus on the 2 things that we're converting from and converting to, thing 1 and thing 2. Now, if you're given a mass of thing 1, then like we were in this problem, then we can go from the mass of thing 1 to moles of thing 1. And the way that we do that is using the molar mass. So this comes from the periodic table. So using a tool that's right in front of you, you can do this first conversion. So no problem. We know how to calculate molar mass. It's going to be the mass of all of the elements that are present in that particular compound or molecule or atom. Now we can go from moles of thing 1, so we got to that part in step 2, moles of thing 1 to moles of thing 2. And we can use that using those molar ratios that we got from the balanced chemical equation. Again, something that was given to us. This should be, ratios. So the molar ratios that we get from the equation are going to get us from thing 1 to thing 2. And then we can go from moles of thing 2 to mass of thing 2, again using the molar mass, which comes from the periodic table. Okay. So what you should be doing as a student of chemistry then is when you first learn about stoichiometry, to get this pattern in your head, then you just have to, commit to being a little bit silly, a little bit Dr. Seussy. And the general pattern is that you're going to go from grams of thing 1 to moles of thing 1, moles of thing 1 to moles of thing 2, moles of thing 2 to grams of thing 2, grams to moles, moles to moles, moles to grams, grams to moles, moles to moles, moles to grams. And you should do this every time you walk. So you take a step and you say grams to moles, moles to moles, moles to grams, grams to moles, moles to moles, moles to grams. So as you're walking around, as you're pacing around your home, as you take a walk around your neighborhood, grams to moles, moles to moles, moles to grams. This is your stoichiometry. Now this is coming from then the molar mass, our equation, and then the molar mass of thing 2. So all of these places that we can find these conversion factors are going to be given to us in some way, shape, or form. We have them on the periodic table. We're given a balanced chemical equation. Or we can balance the chemical equation ourselves. We're just given the reactants and products. We can balance a chemical equation. We're chemists. Okay, so here's the steps. Now let's go back to our problem. So if I have those 5 grams of sodium, and here's my reaction. We balance the chemical process. Now our first step is going to be to identify thing 1 and thing 2, right? So that's going back to our steps here. We're going to ID thing 1 and thing 2. We said that thing 1 is the thing that we're given information about. So that's going to be this guy. So 5 grams of sodium. That means this is my thing 1. In the following reaction, how many grams of sodium chloride can I make? So it's asking the question about grams of sodium chloride. So my sodium chloride is my thing 2. So the thing I'm given information about, the thing I'm asked for information about. And the nice thing is it's not giving me or asking for any information about chlorine, so I'm going to keep it out of the equation. I'm not even going to think about it. I'm just going to focus on going from thing 1 to thing 2, and nothing else really matters. Okay, so grams to moles, moles to moles, moles to grams. So I'm going to go from grams of sodium to moles of sodium. So I need grams of sodium to moles of sodium. Grams to moles. Now I'm going to go from moles to moles. Moles of thing 1 to moles of thing 2, which I've already identified in my equation above. And again, I'll plug in my numbers later. I'm just focusing on the roadmap of my units here. And then in my third conversion, I can go from moles of thing 2 to grams of thing 2. Grams to moles, moles to moles, moles to grams. All right, so we have the roadmap set up. Now we have to plug in the numbers. So I need to go to the periodic table, and I need to find my molar mass of my sodium. So for every 1 mole of sodium, there are 22.99 grams of sodium. Now I use this molar ratio that comes from my balanced chemical equation. So I'm going to use my coefficients in the front of my terms here. So for every 2 moles of sodium, I have 2 moles of sodium chloride. Now, if you're kind of snappy and you have good math sense and you're good with numbers, then you could reduce this down to 1 to 1. You know, you could look at that and say, well, they're both the same number. It's the same as multiplying by 1, although they're all technically the same as multiplying by 1, as we've discussed. But for the time being, I like to be really explicit, especially as we're learning this technique, of where these numbers come from. So the 2 sodium here are reflected in the 2 moles of sodium here. The 2 moles of sodium chloride here are reflected there as well. So 2 to 2. It's not going to hurt anything to have the 2 to 2 there, which really explicitly shows where you got it from, which is your balanced chemical equation. Now the other piece of information I need is my molar mass for my sodium chloride. So for every 1 mole of sodium chloride, I need to take the masses of my sodium, which we already said was the 22.99, and then I need to find my chlorine, which is over here for my 35.45. So together, when I add those together, I get 58.44 grams. And now I can run my numbers. So before I can do any rounding or anything, we want to just make sure that my setup is okay. So we've already made sure that the units line up the way we want them to. Now let's think about our answer. What are we expecting the answer to be? Is it going to be bigger than 5 or smaller than 5? That's always a good check to make sure that our calculator doesn't lie to us. Well, it looks like I'm going to have bigger numbers on the top than I am on the bottom, so I would anticipate that I'm going to have a number that's larger than 5. And when I'm rounding my answer, I have 4 sig figs in each of these guys. These molar ratios are all just counts, right? I'm counting how much it is. It's an exact number. So I'm going to be limited by my mass here, which has 3 significant figures. Those zeros after the decimal are significant. So I'm expecting a number that's larger than 5, that I'm going to round to 3 sig figs. So then when my calculator spits out an answer that looks like this, 3, 8, etc., then I would say, okay, I need to round this to 3 significant figures. 1, 2, 3. I'm looking to the 0 then to round. That means I'm going to round down. So I have 12.7 grams of sodium chloride that are produced from those 5 grams of sodium. All right, so that's stoichiometry. We'll do some more practice with that, but this is a quick little introduction to kind of the steps in the process and a little example. So I'll talk to you again soon.